The International Maritime Organization is implementing new regulations aimed at reducing carbon dioxide emissions of existing boats and ships. In December of 2023, any vessel failing to meet the new efficiency standards will be fined. Graphite Innovation Technologies, a startup in Dartmouth, Canada, has come up with a new coating which can be applied to the hull of a boat, reducing fuel consumption by over 20%. Mo, graphene is one of the most promising new materials that's been discovered, with a myriad of applications, many of which are not even known yet. How is graphene going to transform the world?
Graphene has fantastic properties like strength and flexibility and all kinds of stuff. We integrated it into coatings, and so we made a coating out of it. We knew that this paint is very nice and smooth, so we realized, okay, why don't we try it for vessels?
And the coating is showing great promise in reducing fuel consumption. How does that actually work?
We knew that this coating has frictionless properties. So the Canadian government posed a challenge to reduce greenhouse gas emissions. So we thought, okay, this is a really good, interesting challenge to really get into and actually prove the property. And we applied this coating onto several vessels, some of which seen very promising results, especially when they go onto the water and actually see that skin friction effect happening.
Well, what was really interesting for me as well is not just reducing friction to benefit fuel consumption reductions, but there was also this anti-fouling and non-toxic leakage into the environment, right?
Part of our mission as a team were to really reduce the amount of paint and also reduce the amount of toxins used in paints for vessels. We really understand that a very big LPG tanker, which is a very 200-meter vessel tanker, will use up to 1.9 tons of copper. And copper is very, very toxic.
Very damaging.
Very damaging. So traditional coatings, they leach out amounts of these copper to really kill what's around them. That's how they killed fouling conventionally. But we brought the idea of, okay, if we're really smooth and make it really hard for these organisms to stick on it.
So they can't even attach themselves.
They're smart. They're very intelligent species. So they can stick, but if you're moving at all times, they fall off. So it's hard to grab. The interesting part of it is it's non-toxic. There's other technologies that work kind of like this, but they're out of silicon, and silicon is bad for the environment, especially because it releases silicon oils, and they are toxic.
So for Graphite Innovation Technologies, from here where you are today, Mo, what is the expansion plan into other applications of graphene technologies?
Instead of really applying this coating only in the hulls, we decided to branch out and apply this coating to the propeller of the vessel. The propellers are very important parts of the vessel, where the efficiency of the vessel really depends on the propeller so much. So if you have fouling and things like that on the propeller itself, then it will reduce, creates cavitation, makes the engine work harder, you're paying too much fuel.
And reduces thrust, I assume.
Yes,
actually.
100%. So we designed another coating that sticks on the propeller alloys and does not use toxic materials. So it's another innovation for the propeller. But expansion outside the realm of marine, we see this being applied in hydrodams, so big hydrodam applications, and also...
How would it work in hydrodams?
Hydrodams use a amount of, the way the hydrodam really works is water flow makes that energy happen.
Yeah, it turns the turbines.
The faster you make the water go through,
the
better, the more efficient the turbine will be.
So by eliminating friction through the dam,
yes,
you'll be able to get faster flow of water and therefore more power generated.
Yeah. So the main idea here is to really reduce the amount of paint we're using, because dumping a lot of paint in the ocean is becoming a huge concern. And we are able to really cut the amount of paint used for a single vessel by 50%, about 1.9 or 1.2 tons of paint on an LPG tanker application.
In terms of the results, the fuel consumption profile, How have you been able to quantify those benefits?
To quantify this, you need to do apples to apples. So you need to measure how the vessel was doing beforehand, before the coating, how is the vessel doing without a coating, and how is the vessel doing with a coating, so that you understand the range of what is the effect of the coating. And that's exactly how we're doing it. And we've done it in different vessels, and we're realizing upwards 25% savings right when you launch them. But we'd say a life cycle average will be around 10 to 12%, which is huge in the bottom line.